In this video, I'm going to be going over some of the problems, I should say the problems that we didn't cover in class on the review. So let's look at number 2. So here we're adding, subtracting, multiplying, and dividing complex numbers, particularly imaginary ones. And it actually works a lot like it would as if these were x's instead of i's. But we have to remember that I squared is equal to -1. And so anytime we get an I squared, we can simplify that. So let's go ahead and get started. So let's see, on letter A here, we're going to drop the parentheses first. And then let's go ahead and combine our like terms. We get a -2 and 7, that's 5. 4i and a -10i will give you a -6i. And so that'll be our final answer. And it's in the right form, that a plus bi form, which is what we'll write all our answers in. So on part B, you're going to have to distribute that negative. So we can drop the parentheses on the first binomial. And then don't forget to distribute. Basically, you're distributing a -1 here. And so again, we have some like terms. We've got the 12 minus 4, that's 8. And -3i and a +9i give you 6i. On letter C, you're going to be foiling. So we can multiply our first terms, we get 12. The outer terms, we get -8i. Our inner product is -15i. And our last product is 10i squared. We can combine our I terms. We'll have 12 minus 23i. Now remember, I squared is -1. And so really we've got 12 and -10. We can combine those to get 2. So our final answer is 2 minus 23i. Now be careful on D. You don't just square the 2 and the 7i separately. That 2 tells me I need to multiply 2 of these. I call this FOIL in disguise. So we end up with 2 plus 7i times 2 plus 7i. And we're going to FOIL this. So we get 4, 14i, inner product is 14i, and the last product is 49i squared. And let's see, we know the I squared is -1, so that's -49. With the 4, you're going to get -45. And 14i and 14i will give you 28i. All right, so finally we got letter C here, or letter E here. What we learned is in this situation we cannot have an I in the denominator of a fraction. Otherwise we're not in this a plus bi form. And so we learned a little trick. We can multiply our denominator by the conjugate, and that'll work to get rid of the i's. So we'll see that in a minute here. Of course, we can't just multiply the denominator by 5 minus 3i. To make it legal, we also need to multiply the numerator by the same thing. So what we're really doing is multiplying by something that's equal to 1. So that's what makes this work. And so we're going to FOIL. We're going to multiply the binomials in the numerator and the binomials in the denominator. We're going to FOIL here. So we get 10 minus 6i minus 5i. The last product there is going to be a +3i squared. Now remember, with conjugates, we just need to multiply the first terms and the last terms. You can do all the 4 products, but you'll always have 2 of them will be opposites, the inner and the outer product. So let's multiply our first terms. We get 25. Our last terms, we get a -9i squared. And then we need to clean all this up and simplify. So in the numerator, remember that's 3 times -1, since I squared is -1. So we can combine the 10 and -3 to get 7. -6i and -5i will give you -11i. In the denominator, the I squared again is -1. So this is 25 plus 9, and that's 34. Now again, we want to make sure we're writing our answers in this a plus bi form. So we'll break this into two fractions, 7 over 34 minus 11/34 times I. All right, let's move on to the next page. It says circle the rational numbers that are not integers. Well, first of all, let's throw out the irrational numbers because everything else would be rational. Remember, rational numbers are numbers that can be written as a fraction, and in decimal form they either terminate or they repeat the decimal pattern. And so let's go ahead and throw out our irrational numbers. Notice that's an irrational number. We don't have any repetition. There is a pattern there, but it's not a repetition of the same digits to the right of the decimal. Anything with a pi in it's not going to be rational. And then square roots, whenever you can, when you're not taking the square root of a perfect square, square root of 10, that's going to be irrational. So what's left is our rational numbers, but we need to circle only the ones that are not integers. Well, the first one, 1.16, certainly isn't an integer. Now, square root of 64, that's actually 8, which is an integer. Now remember, the integers are these guys. Our negatives, 0, and our positives. And so 3 2/5, that's a good one. That's definitely not an integer. Same with 3.294, so the 294 repeats. Notice negative 5 and 29 are integers, so we'll get rid of those. Negative 19/4 is rational but not an integer. And then finally 0 is certainly an integer. And so these are the ones in green here. The ones that I circled are the ones that are rational numbers but not integers. All right, on number 4, we're going to solve each of these quadratic equations using the method of our choice. Now remember, you always want to try to factor first. Factoring is our method of choice if we can use it. Now, the first one there looks like we might be able to factor out a GCF, but first we're going to have to get 0 on one side. Notice both of those terms are divisible by 3x. That would be the largest or the greatest common factor. And it'd be 3x times 2x and 3x times minus 1. And so we've got 3x times 2x minus 1 equals 0. And we can set each of those equal to 0. So 3x equals 0 or 2x minus 1 is equal to 0. So 3 times x is equal to 0. That means x must be 0. And on 2x minus 1 equals 0, let's go ahead and add 1 to both sides. Divide by 2. And so we get 0.5. Now on b, there's no x term. So normally this would indicate that we would want to use the square root method. Now sometimes we may be able to factor these if we end up with a difference of squares. But the safe bet will be the square root method. So let's go ahead and divide each side by 2. Remember, with the square root method, we want to get x squared by itself and a number on the other side, and then we can take the square root of both sides. So this will be x squared is equal to negative 16. And in fact, if you had moved this 16 over, this doesn't factor. So we take the square root of both sides. And of course, the square root of negative 16 is 4i. So we get x equals plus or minus 4i. Now on 4c, I'm hoping that I can factor using the AC method. If not, I would have to go to the quadratic formula. So we need two numbers that multiply to negative 18, that's my AC, and need to add to negative 7 my B term. And so you could try the different factors of 18. 2 and 9 are the ones that work, and you need to make the 9 negative. So notice 2 times negative 9 is negative 18. and 2 plus negative 9 is negative 7. So we'll split our b term, and now we can factor by grouping. This is what I mean by the b term. And so let's see, we've got, we'll group the first two terms, and we can factor out the GCF of 2x. And then it'd be 2x times 3x and 2x times a plus 1. Now the nice thing about doing these is we should get the same thing in parentheses, or if we've made a mistake. So when I factor these two terms, I'm expecting a 3x plus 1. So really I just need to figure out what times 3x plus 1 gives me minus 9x minus 3. So to get that minus 9x, I'm going to need a negative 3 there. And notice negative 3 times 1 also gives you the other negative 3. All right, so we have two terms, and the GCF, or the greatest common factor, would be 3x plus 1. If you cross those out, you can see the other factor is 2x minus 3. Now remember, we're solving an equation, so we'll set each of our factors equal to 0. We've got 3x plus 1 equals 0, and 2x minus 3 equals 0. So for 3x plus 1 equals 0, we'll subtract 1 on both sides, and then divide by 3, and we get x is equal to negative 1/3. For the other one, we're going to add 3 to both sides. We get 2x is 3, equals 3, so we'll divide by 2, and we get x is 3/2. All right, we got one more on this page. It says solve by completing the square. So first of all, we learned that with this type of problem, we got to isolate the x squared term and the x term. So let's subtract 5 on both sides. And so we get x squared minus 12x equals negative 5. So now we need to complete the square on the left. So I like to write it this way. I'm just going to put plus a square on each side with an actual square. And so we've got x squared minus 12x plus some number on the left. To complete the square, we want to take half of the b term, that negative 12. So half of negative 12 and square that, and that would be negative 6 squared, which is 36. So we're going to add 36 to both sides. Now we need to write the left side in perfect squared form. So it'll be x minus 6 squared. Remember, minus 6 is half of the negative 12. That'll always be half of whatever your b term is. It's actually the number that you squared to get the 36. Notice on the other side, 36 and negative 5 is 31. So the whole point of completing the square is now I've created a perfect square equal to a number, and I can use the square root method to solve this. All right, so we're going to take the square root of both sides. We're going to get x minus 6 is equal to plus or minus the square root of 31. And we need to add 6 to both sides, so we get x is equal to 6 plus or minus the square root of 31. All right, let's move on. It says find the zeros of each function. So basically a 0 is an x value that you plug into the function and your output's going to be 0. So to find these zeros, we actually are going to set the function itself equal to 0. So let's go ahead and do that. So we have 3x squared minus 18 equals 0. And to solve that, now first of all, there is no x term, so I would be thinking I want to use the square root method. So let's add 18 to both sides. Remember, our goal is to get the x squared by itself, and then we can divide by 3. We get x squared is equal to 6. We'll take the square root of both sides. We get x equals plus or minus the square root of 6. On part B, we've got g of x equals x squared minus 3x minus 54. We'll set that equal to 0. And so let's go ahead and factor this using the AC method. If that didn't work, we'd have to use the quadratic formula. Notice here 6 and 9 are going to work, and I need the negative 9 to be negative to make this to make it work. So 6 times negative 9 is negative 54, and 6 plus negative 9 is negative 3. So we have x plus 6 times the quantity x minus 9 equals 0. We're going to get x equals negative 6 and 9. So remember, these are zeros, and you could always plug it into the function. You could plug in 9 or negative 6, and you would see those values make the function equal 0. All right, the only technique we haven't used is quadratic formula. So on 7, that's what we're doing. So we've got 2x squared minus 2x plus 5 equals 0 for a here. So I'm going to go ahead and write the quadratic formula. Now remember, our a here, actually I'm going to make a, what I call a shell for that. So wherever there was variables, now there's parentheses. And a here is 2, b is negative 2, and c is 5. Sorry, I seem to be losing my voice here. Excuse me. All right, so let's plug in b, which is negative 2. And we'll plug in our a's. And so that's also, let's see, a is actually 2, and c is 5. And so we've got x is equal to a negative 2, that's positive 2, plus or minus. We've got the square root. Now we're going to first square the inside there. That's negative 2 squared is 4, minus, we have 4 times 2 times 5, or 8 times 5, which is 40. 4 minus 40, you're going to get negative 36 there. And so in the denominator, 2 times 2 is 4. Now the square root of negative 36 is actually 6i. So I'm going to go ahead and break this into two fractions, 2 over 4 plus or minus 6i over 4. And finally that reduces to 1/2 plus or minus 3/2 times I. All right, you may want to try to do b, and then you can watch the video and make sure you did it right, or you can look at the notes. All right, so first thing you need to do here is you need 0 on one side. Now you might be tempted to move the 2x squared, but I want to keep that 2x squared positive. I mean, you can do it a number of ways, but I want my x squared term to be positive. So I'm going to go ahead and subtract 5x and 1 on both sides. So I end up with 2x squared minus 5x minus 1 equals 0. So a is 2, b is negative 5, and c is negative 1. I'm going to go ahead and write down the quadratic formula, and let's make a shell. So wherever there's variable, now there's parentheses, and I'm just going to plug in my a, b, and c. So b is negative 5, a is 2, and c is negative 1. And let's go ahead and simplify this. You're going to get x equals a negative 5 is 5. Inside the parentheses, we've got negative 5 squared, which is 25, minus, you've got 4 times 2 times negative 1, that's negative 8. And when you add those, you're going to get 33. So this is plus or minus the square root of 33 all over 4, which you could also write as 5/4 plus or minus the square root of 33 over 4. All right, let's move on to number 8 here. So this is one that we said was quadratic in form. What do we mean by that? Well, notice if you had this equation, x squared minus x minus 12 equals 0, that is a quadratic equation, and we would use the AC method. We need two numbers that multiply to negative 12 and add to negative 1. 3 and negative 4 are the numbers that work. We would write this as x plus 3 times x minus 4 equals 0. And so we would get negative 3 and 4 for solutions. Now our equation is not quadratic. It's actually a fourth degree polynomial. And so it's going to be similar, it's going to be different, but it is quite similar in how we solve it. Instead of having x times x, well, x times x is not x to the fourth. Those are going to both need to be x squareds. But otherwise it's the same. We're going to plug in our 3 and our negative 4. Notice 3 times negative 4 is negative 12, and 3 plus negative 4 is negative 1. It's just like in the other one we were just doing here. So, but notice here we've got two quadratic equations. We're going to say x squared plus 3 equals 0, or x squared minus 4 is equal to 0. And we'll solve each of these separately. So for x squared plus 3 equals 0, let's subtract 3 on both sides. We get x squared is equal to negative 3. And let's take the square root of both sides. Now remember, if you have the square root of a negative, you're going to have an imaginary number, so we need to pull out an I. You get x is equal to plus or minus square root of 3 times I. All right, on the other part, you got x squared minus 4 equals 0. That's going to be x squared equals 4 when we add 4 to both sides. And let's take the square root of both sides, and you get x is equal to plus or minus 2. And so we have 4 answers: square root of 3i, negative square root of 3i, 2, and negative 2. Notice that's a fourth degree polynomial, and we got 4 answers. So that's what you should expect when you solve a fourth degree polynomial. Let's go, and we'll talk more about that later on. Let's go ahead and move on to, we're going to skip this part here. We've already done these, or we did these in class. So on number 11 here, we're solving for c, but c is in the denominator of a fraction, so I need to clear the fractions. We've got w squared. Let's see, so our LCD is LC. We're going to multiply both sides by LC. So on the left, you're going to get LCW squared. On the right, the LC's cancel, and you're left with 1. So let's see, we're solving for c. C is multiplied times L and W squared, so we need to divide by both of those. So L and W squared, or LW squared. So on the right we have 1 over LW squared. So finally we're going to get C is equal to 1 over LW squared. On part B, our LCD, now x, y, and z are all in the denominator. We're just going to multiply those. So the LCD is x, y, z. Let's go ahead and multiply each of our terms by x, y, z. So when we multiply x, y, z times 1 over x, the x's are going to cancel and we're left with y, z. When we multiply x, y, z times 1 over y, the y's cancel and we're left with xz. So that'll be plus xz equals, notice on the right, the z's cancel and you're left with xy. Now here's where it's a little bit tricky. We're solving for y, and notice there's 2 terms that have y in them. And so those terms are going to need to be on the same side so that I can get y by itself. So let's go ahead and subtract yz from both sides. You get xz is equal to xy minus yz. Now, on the right, we have y in both terms. They're not like terms. X, y, and yz have different variables. They don't have the exact same variables, so we can't combine them. But what we can do is factor out a y. So we're going to get xz is equal to y times, let's see, x times y would give you the xy, so we need an x here. And let's see, I need a minus yz, so I need y times z there. And so notice now we can isolate the y by dividing both sides by x minus z. So finally, we're going to get y is equal to xz over x minus z. All right. Oh, I'm trying to hold it together. It's late and I'm falling asleep, but we're almost there. So let's look at c. So we got s is equal to the square root of a over 6. So the first thing I need to do if I'm going to solve for a is I got to get rid of that radical. So we're going to square both sides. We get s squared equals the square root of a over 6 squared. So we're going to get s squared is equal to a over 6. We know that when we square a square root, we get what's under the radical. And then in order to get rid of that 6 in the denominator here, I'm going to have to multiply each side by 6. So we get 6s squared is equal to a. And in fact, we have solved for a. All right, last problem. So we discussed the fact that the profit function is equal to revenue minus cost, or which are the Rx function and the Cx function. And so here and this is when X is the number of units sold. So you're producing some kind of product like bikes or whatever it is, and X is the number of bikes or the number of units sold. It could be any product. So we're given Rx is equal to 50x minus 0.5x squared, and C of x, or our cost function, is 10x plus 3. So I'm going to go ahead and plug those in to the formula. So P of x is equal to R of x, which is 50x minus 0.5x squared, minus C of x, which is 10x plus 3. So we're just going to have to distribute here and combine like terms. Notice I'm going to put the x squared term first, so negative 0.5x squared. I can combine 50x and a minus 10x to get 40x, and then the minus 3. So P of x is a minus 0.5x squared plus 40x minus 3. So that is the profit function. Notice it's a parabola that opens down, and so we should have a maximum. Where do we find maximums? At the vertex. So we need the vertex formula. That's x equals negative b over 2a. And in our problem, a is negative 0.5, negative 0.5, and b is 40. So we have negative b, or negative 40, over 2 times a, which is 2, so we have 2 times negative 0.5. So that's going to be negative 40 over 1, negative 1, which is 40. So we just found the x value of the vertex, that's 40. And now we need to plug that into the function to find the corresponding y value. So I'm just going to plug 40 into the function. And when you do that, you should get 797. So our vertex is the point 4797. Now remember, the 40 there is my x value, which represents the number of units that have to be sold to get our maximum product. And the 797 is the y value of the vertex, which would be our maximum profit. A maximum or minimum is always the y value of the vertex. So finally, I'm ready to answer this. Notice it says write your answer using a complete sentence. So on the test, you'll have to do a problem similar to this, where you'll give your final answer in a complete sentence. So here I would say the maximum profit of $797 occurs when 40 units are sold. All right, and that'll be it for this video.